Since we're dealing with ethane to prepare our samples, we have to realize that ethane is a combustible and also potentially explosive gas. Now, for a safety hazard, there's a number of values that we need to consider when we're dealing with ethane. And those are these values here on the board. The first one is the lower explosive limit of ethane. So that is 3%. And this means that whenever you have a volume in a room and 3% of that volume consists of ethane, then you are in a situation when, if there would be a combustible source there, a spark or candle or a match, then you have an explosive situation. Whenever the amount of volume in that room is less than 3%, no matter if there is any ignition in that room, you will not get an explosion. So you always have to make sure that when you're in a room that has ethane, that the concentration of ethane in that room is below this 3%, so below the lower explosive limit. The second important value is the expansion factor, and we don't know it exactly for ethane, but this is for a liquid natural gas, which is mostly methane. And also, as a comparison, we'll have liquid nitrogen here on the board as well. And for liquid natural gases, this is 600. And this means when you have a liquid methane or liquid ethane, when you transform that liquid, when that liquid evaporates in gas, you will get an expansion of a factor of 600. So 1 liter of methane liquid will transform into 600 liters of methane gas. Same goes for liquid nitrogen. If you have 1 liter of liquid nitrogen, that will be 700 liters of nitrogen gas when it will evaporate. And the last one is a cubic meter. This is 1,000 liters. So for the calculation that I will be doing, I'll be using standard international units. So most vitrification equipment is in a room the size of, let's say, 3 meters by 4 meters by 2.5 meters high. And this would be a volume of 3 times 4 times 2.5 is 30 cubic meters of volume. Now 30 cubic meters equals 30,000 liters of volume. To end up in an explosive situation, 3% of this volume can be ethane. If it's less than 3%, you're safe. If it's more than 3%, you're not safe. Now 3% of 30,000 liters, 1% is 300 times 3 is 900 liters of ethane gas. So that means if you have a room this size, standard room, if you have more than 900 liters of ethane in that room, you are in an explosive hazard. So if there is a spark, potentially the room might or actually will explode. That has implications for the bottles that you use to store your ethane in. And there's 2 types of storage bottles. You can store your ethane in a gas bottle that holds a liquid, so liquid ethane, under pressure. Or you can have a gas bottle that stores ethane as a gas. Now, if you have a bottle in this preparation room that is just in the open space without any safety cabinet around it, you have to realize that if you have a bottle of, let's say, 10 liters of ethane liquid in the open space in a lab space, that 10 liters of liquid ethane, if the bottle would be leaking, might transform into 600 times, so is 6,000 liters of ethane gas. So if you have a 10 liter liquid ethane bottle that is leaking in your lab overnight and all of it would evaporate out, then you end up in your lab with 600 liters of ethane gas in a space of 30,000 liters, which is more than 900, so any spark would ignite the room and blow up the building. That obviously is a dangerous situation. So therefore, if you don't have any protective cabinet in your lab, you should not use ethane bottles that contain a liquid, because they are potentially an explosive hazard if the bottle would be leaking. Then if you have a gas bottle of say 20 liter of gas in the open space, that would be perfectly safe, because this 20 liters of ethane gas is way below the 900 liters of the lower explosive limit. So if you want to use bottles that contain liquid ethane, you should install a safety cabinet in your lab, and that safety cabinet will prevent if the bottle is leaking, because the safety cabinets are ventilated continuously, and also they're locked with very heavy doors. So if there would be an explosion, the explosion would be contained inside the safety cabinet, and also a possible leakage from the bottle is continuously ventilated out. That also brings me to another point, that if your lab space is continuously ventilated, of course, if a bottle would leak ethane, you might still not end up in an explosive situation. So this is only the case if the room is completely sealed and all the ethane would be evaporated. But it's good to be aware of these numbers. Now, these numbers are still quite large. 900 liters is quite a large volume still. So let's now consider the volume of liquid ethane that we work with daily when we're freezing a specimen. So we're freezing a specimen in this ethane cup, and the volume of that ethane cup when completely filled is about 7 milliliters of liquid ethane. Now the 700 milliliters of liquid ethane times 600 will create, if everything is completely evaporated at once, 4.2 liters of ethane gas. The space that is 4.2 liters goes into, if that goes into a complete lab, obviously this will never ever explode. So the smallest space in which this 4.2 liters will form an explosive hazard, again we have to calculate that with 3%. So this 4.2 liters would be 3%. So if 4.2 liters equals 3%, then 100% equals 140 liters of volume. 140 liters of volume is a box of roughly 50 by 50 by 50 centimeters. So half a meter by half a meter by half a meter, or if we do it in inches, this is about 20 inch. So basically this amount of liquid ethane will always be in a space that is larger than a box of 50 by 50 by 50 centimeters, and therefore there is no hazard of any explosion when dealing daily with the amount of liquid ethane that we're actually working with. Now, I've been to many labs, and there always has been a concern about the safety hazards about this liquid ethane. We now know that an explosion will not occur. However, you have to realize that liquid ethane is still highly combustible. And to demonstrate what would happen if you ignite this amount of liquid nitrogen, we have recorded a video that shows that.